So we've just looked at how to find the gradient of a parabola, but let's try something harder. Let's try to find the gradient of any polynomial. So, to find the gradient of any polynomial, what we need to be able to do is first of all define what we mean by a polynomial. So a polynomial is some sort of function where all of the components are of this form. So it would be ax to the power of n, where n is some integer, and then it could be b to the power of xn minus 1, and so on, plus there could be as many of these terms as we like. So a particular example that we could do is we could have a go at doing, let's say, 2x cubed plus 3x squared. So in this case, our a would be 2, and our n would be 3. And then our b would also be 3. And we could have extra terms. It could keep going. Now, in order to be able to find the gradient of this polynomial, we actually only need to consider one term at a time, because all of the forms are essentially just some constant multiplied by x to some power. Now, before we're going to be able to do this, we need to know a theorem, and this theorem is essentially for expanding any polynomial, and it is called the binomial theorem. Now, essentially, how the binomial theorem works is it can tell us how we can expand any of these polynomials. So if we were to try and expand, let's say, this first term here, let's suppose that instead of it being x, it was x plus some other number, so x plus y or x plus h. So we could expand this to be, in this case, we would get x to the power of n, then we would get n, x to the power of n minus 1 multiplied by h. And then if we're having a look at the next term, so our next term is n factorial over n minus 2 factorial, 2 factorial. That's our constant out the front. Then it would be x to the power of n minus 2, h squared. And every term from then on is going to have a higher power of h and a lower power of x. So what we're going to do now is we're going to take the term ax to the power of n, and we're going to try and find its gradient. So to do this, what we're going to do is use our formula that we had before. So our gradient, or m, so I'll just call it m for now, is equal to the limit h approaches 0 of the function x plus h minus the function f of x divided by h. Now I'm going to substitute in my value for the function, and so that means I'm going to get, okay, now if I do my expansion, what I'm going to do is I'm only going to consider the first three terms. All the other terms have higher powers of h. So it's going to look something like this. Okay, so I get this term here. Now, first thing I'd like to do is cancel out the x to the power of n's. That's nice. Then what I'm going to do is I'm going to cancel my h's. So my h cancels with the first term that's remaining, and it also cancels out with one of the h's in the next term. But there's still a h left over in that term, and all the other terms that are remaining. So when I set the limit of h is equal to 0, this term will go away, this term will go away, it will be 0, and so will all the other terms that I've represented with dot dot dot. So we're actually just going to be left with this little bit here. And that's going to be equal to a n x to the power of n minus 1. So what we have done is we've found a way of calculating that gradient at any location. So let's just summarize. If I had the function ax to the power of n, the gradient is equal to a n x to the power of n minus 1. So let's just look at a specific example. Let's suppose that we take 2x cubed. In this case, the gradient of my function would simply be, so I've still got my a, that's 2. My n that I've raised to the power 2 is 3, multiplied by x to the power of n minus 1, so 3 minus 1. So that would be equal to 6x squared. So this would be the gradient if I had this cubic function just here. Now we have a special terminology that we use for the gradient. We call it the differential. And there's different symbols that we use for the differential. But if we are taking a function and differentiating it with respect to x, so we're seeing how does the function change with respect to x, then the notation that you often see is f dash x. This is the gradient of fx with respect to x, which means as you change x. You may also see it the word, rather than the word gradient used, they call it the differential. Now, sometimes rather than using this fx notation, sometimes people just use the letter y. So if you see that, if they want to differentiate y, or find the differential, or the gradient, with respect to x, sometimes you'll see this y dash, so that is the gradient, or sometimes you see this notation here. It means the same thing, dy dx. So this means how does y change as x changes, and we call that the differential of y, or we call that differentiating y with respect to x. So this is pretty exciting. You have just learned differentiation, which is the first step on the road to learning calculus.